me the whole time, including the remarks.
Okay, 10.4. We're going to talk about finding probabilities of disjoint and overlapping events. What that means is this. You can have events A and B, and we need to figure out like if they are connected or if they are not connected. Put it in there. That's fine. If your events focus, hey, you are going to move soon. Yes.
You lost the
Okay, so if you have events A and B, they can either be dependent on, they can like overlap and be a compound event, or they can be disjoint or mutually exclusive where they don't overlap and it doesn't, like one doesn't affect the other. If they overlap, okay, overlapping events, like here and here, this is called the union of events, okay? The middle section where they overlap is called the union, meaning if they ask you for the probability of A and then this U and then B, that means they want the probability of this union, this overlapping portion right there. So if you hear that word, the union of something, that's what it means. It means that overlapping section. When you are finding the probability of these, okay, two events overlapping are if one has more outcomes in common in the first diagram. Two events are disjoint or mutually exclusive if they have no outcomes in common, such as the last diagram. Probability of compound events is one of two formulas. You're either going to use probability of A or B, where it equals the probability of A, so like the first circle, plus the probability of B, the second circle, minus the probability of A and B, meaning the probability of that overlap. Okay, I can't count the overlap twice, and that's what happens when I count A plus B. They share something, it's overlapping, so I can't count that twice, I have to take it away from it. Now, the other type of probability for disjoint, the probability of A or B happening, is simply the probability of event A happening plus the probability of B. Because when they're disjoint, they don't overlap, so I don't have to subtract anything from it. It's the same formula, except for the fact that when they don't overlap, when they're mutually exclusive, when they're disjoint, I would just be subtracting 0 from it, so they don't put that part in there. They just took that out of the formula. Okay? So it's the same exact formula. You can use the same exact formula for both. Just if you use this formula for a disjoint, this is always 0, because there is no overlap. So then, it says a card is randomly selected from a standard deck of 52 cards. What's the probability that it is a 10 or a face? When it says or, that's when I know I'm using that formula. If it says or, I use the formula. It says probability of A or B. I like to rewrite the formula out. Probability of A or B. And then I like to match things up to what they are and plug numbers in for them to make it a little easier. Okay, so it says, what is the probability that it is a 10 or a face card? Well, let's make A the 10, since it's in that A circle or A oval. What would be the probability of drawing a 10 out of a deck of cards?
4 tens.
So 4 out of 52. So I plug that in right here. What would be the probability of drawing a face card out of a deck of cards? There are not 16. There's 12 face cards. 12 out of 52.
What are aces in?
Aces don't count as like numbers or face cards. They're their own thing. Okay. And is there any overlap in either of these? No. So do I have to subtract anything from it? No. So I get 4 plus 12, which is 16 over 52. What does 16 over 52 reduce down to?
5 by 2, you get 30.
4 over 13.
4 over 13. So 4 over 13, is that right? So 4 over 13. So you have a 4 in 13 chance of pulling out a 10 or a face card. Yes.
Okay, so just so I'm on the same track, only when they're overlapping is when you subtract.
Yes.
Okay.
Because technically if I subtract right now, it would just be minus 0.
Okay.
So it's going to come out the same thing. It just saves you a step. Okay? So that's one way that we can solve this. What happens if it says a card is randomly selected from a standard deck of 52 cards? What's the probability that it is a face card or a spade?
Well, that's when they overlap each other.
Yes, so I have the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. What's the probability of A? It would be a face card. What? Nope, 12. There are 12 face cards in a deck of cards. 12 over 52. What's the probability of pulling out a spade? 13 out of 52. What's the probability of getting a card that is a face and a spade? 3 out of 52. That's where this probability comes in. The probability of the overlap. And because there's a diagram, that should be easier to do. When there's not a diagram, you might want to draw it out yourself. Or you need to list stuff so that you can see where the overlap happens, okay? 12 over 52 plus 13 over 52 minus 3 over 52 gives you what? 22 over 52. What's that reduced to? You always have to reduce. What can go into both of them? 2, 11 over 26. So you have 11 and 26 chance of pulling out a card that is either a face card or a spade. Now we come to setting it up completely on our own. Out of 200 students in a senior class, 113 students are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes, 51 seniors who are on the honor roll. What's the probability that a randomly selected senior is both a varsity athlete and or on the honor roll? One sentence at a time.
Okay, so.
There's 200 students.
So that would be what my fraction has
Our
underneath.
bottom, our
Yes.
denominator.
So there are 200 students. The second sentence says 113 students are either varsity athletes or on the honor roll.
So 200 is So.
No, 200 is needed.
Would it be
Because that's your denominator.
74 over?
No.
It would be 74 over 200 plus 51 over 200.
Good. Yes, yes, yes. Okay.
Yes.
So, do you see where it says 113 students are either varsity athletes or on the honor roll?
Yes.
Where in here does it have or?
At the beginning.
At the beginning. So you say 113 over 200. Out of 200 students, 113 are either on the honor roll or are athletes. Now, what's the probability for A? Just go to the next sentence.
74 are varsity athletes.
74 over 200. That represents athlete. Yes.
And then
51
51.
over 200.
And we're trying to find what's the probability that a randomly selected senior is both a varsity athlete and on the honor roll. See how that says and? I'm trying to find the and, the overlap. Trying to find the people that are both. So, how can I solve that? What do I need to do?
So.
Yep, 74 plus 51 is what?
125.
125 over 200. Now, how do you solve from there?
Subtract.
Yep, subtract, what's 113 minus 125?
12.
Yes. Negative 12 over 200 equals negative probability of A and B. So basically, I divide by that negative, right?
Yes.
And the probability of A and B equals 12 over 200. What's 12 over 200 reduced down to?
Divide by 2, you get 6 over 100. Divide by
Both are divisible by 4. which would give
So
you,
3 over
50. 3 over 50.
and what
Whoa.
is 3 over 50 decimal wise, just to give you a rough estimate of how many students did this?
6%.
Yeah.
6 out of 100.
And it shouldn't be
Why not
3 out of,
Yeah,
oh yes, it would be 6. I'm thinking,
good
okay.
job.
So it's 0.06, so only 6% of students in that senior class are both athletes and honor roll. Okay, that's the overlap. Oops. Now, this is like a common sense thing, okay? Common sense. They just word it really funky, so we're gonna talk through it and then you're gonna be like, okay, that's really easy. The event bar A, when it has a bar over it, it's called bar A, okay, or A bar. The event A bar, called the complement of an event A, consists of all the outcomes that are not in A. Meaning, if I said to someone, you have a 60% chance of passing this class with a B, okay? If I wanted to figure out what your A bar was, that would be, what would be the percent of you not passing with a B?
50.
No, I said you have a 60.
Oh,
40.
I think
So you just take 100% and you subtract the 60 from it, okay? Or you take the number 1 and subtract the decimal from it. You're just finding what's not there. The reason we do that is because sometimes it's easier to figure out what is there, to figure out what is there, or to figure out what is there to figure out what's not there, because it's just a simpler method. So the way that is written is through the formula, the probability of bar A bar, okay, equals 1 minus the probability of A. So, on this part, it says when 2 6-sided dice are rolled, there are 36 possible outcomes as shown. Find the probability of the given event. The sum is not 6. So the probability of not 6 equals 1 minus the probability of 6. Yes? How many of those sets of die could add to be 6?
You got those.
So there are
1,
4,
2, 3, 4, 5. So 5 of them add to be 6, correct? And how much is it out of?
36.
How much?
36.
So then what is the probability of it not being 6? 31 over 36. That's what they want you to do. When it says, when it has an A bar there, or that says the probability of not this, I need you to show me your work of 1 minus the probability of what is there, okay? Of the opposite. Part B says the sum is less than or equal to 9. So we want to figure out when the sum is less than or equal to 9. Probability that it's less than or equal to 9, okay, equals 1 minus the probability of it being greater than 9, correct? Okay, what numbers on here add to be greater than 9?
Oh my.
Wow.
Yes, these ones. 1, 2, 3, 4, 5, 6. Okay, so 6 out of 36, correct?
Yeah.
So what's 1 minus 636?
36.
30, 36. What's 30, 36 reduced to?
5, 6.
5, 6.
How'd you get 6?
Because there are 6
Because
ones
there are
that-
6 ones that are greater than 9. The sum is greater than 9.
Oh,
Okay, so that's what you're doing on this stuff. It's pretty simple.
We're gonna get pictures for those ones?
Possibly, or you're gonna see it, well, we'll do another one in a second. This, I'm warning you, includes stuff from like part 1 of this chapter, so think that way a little bit for me, and stuff from this part of the chapter, okay? A restaurant gives a free fortune cookie to every guest. The restaurant claims there are 500 different messages hidden inside the fortune cookies. What's the probability that a group of 5 people receive at least 2 fortune cookies with the same message inside? How do you do that?
Why?
What did you say on the bottom? Yeah, we have to add something to that on the bottom.
5, no.
Let's talk about this. How many people are getting fortune cookies? 5. So think back to some stuff that we did where it said like 5 people of 2.
Is it the C thing?
It could be a combination or a permutation.
Permutation.
But think about, okay, but think about this. It's not going to be a permutation from 500 down because how many total people are there? There's only 5. So what goes in the first blank? How many options does the first person have to receive a message? 500. How many does the second person have?
499.
499. How about the third? Okay, does this make sense right now?
98. Milk on the wall.
1, 2, 3, 4, 5. Yes? Okay, so that's the top part of this. And the bottom part, Stacia was right in saying that it should be 500, but it has to be to the power of how many people are there.
Wow.
Okay? So it's 500 to the 5th. Now, that's if I'm trying to figure out the probability. It says, what's the probability that a group of 5 people receive at least 2 fortune cookies with the same message inside? So what do I need to do with that answer? Because remember I said I'm combining it with stuff that we did today. This would be to figure out how many total possible messages there
Gotta
are.
subtract.
If all 5 got, yes, I need to subtract. Then you take 1 and subtract this from it. So, what is 500 times 499 times 498 times 497 times 496 divided by 500 to the 5th?
I'm gonna do that in my head.
I'm gonna start saying that now. You're just so stuck in my head.
What is that?
Approximately 0.
No, you can.
Yeah.
Oh,
No.
Because I'm dealing with 5. Not just 1, just 5. Okay, so what do we get? We get 1 minus what?
Just scroll
Just
up.
round it to
Well,
2
divide it.
decimal places.
Divided by 5 to the
1 minus what? Point. It shouldn't be that hard. What?
It's 980.
Good, we'll put it at 0.98.
I was
Make it
right.
easy.
Oh, times
No.
So what is that come out to be then? 1 minus 0.98?
2.
0.2. So you have a
0.2.
20%, no, a 2, it's not 0.2, it should be 0.02. You have a 2% chance, right,
Yeah.
of getting 2 people in a group of 5 to have the same fortune if there are 500 total messages.
That's kind of high, I feel like.
Yeah, I know, I thought it would be like a really small percentage. I guess 0.2% is, or, you know, is kind of small, 2%. But I feel like that's pretty good. And then this is another way you're gonna see these problems. You see how it says P A bar up there?
Huh.
So all I have to do when they give me the probability of A is literally say 1 minus 0.45, 1 minus 1/4, 1 minus 1, 1 minus 0.03, and get all of my answers. Okay? So that's why I said this second half should be common sense, because you're just taking whatever you don't want to find and subtracting it from 1 to get your answer. Cool? Okay. Video, please. And your homework is page 710, 3 through 29 on.